Good evening to one all present here today. Today, I'm going to be talking about unsupervised learning. My name is Ganesh and I'm from data science. Uh, so today we'll begin with what is unsupervised learning. So unsupervised learning is basically a machine learning algorithm which is used to analyze and cluster unlabeled data sets. So it's basically a data set which has no labeling to it, you can say. In other words, an algorithm which has a certain pattern and it follows with certain data groupings. For example, we have all men together and all women together. That's a good example. For some examples below, I have taken up the minimum batch means, which is a few examples which we'll be discussing soon. This is the diagram of a graph of DB-scan, and this is k-means. This is unsupervised learning algorithm. So we'll be using different kinds of unsupervised algorithm to solve a problem in the upcoming session. So basically, unsupervised learning is used in our day-to-day lives. So first use of unsupervised learning is that in day-to-day lives, you and your friend are reading a common novels, two common novels, and your friend tends to read another book, which is recommended to him. And when you're reading these two books online, you will be recommended the third book, which is which is by using unsupervised learning. So you have used k-means and dbscan in order to uh, recommend when you're reading these two books, your friend who has read all these two books is also reading this book. So when you're reading these two books, it recommends you to go ahead with the third book as well. In the similar way, when you go to a grocery, you tend to look at the normal Pepsi can or a normal brand which you tend to buy, but then it would recommend you a better brand. Suppose, for your example, you see a normal can, and here the Duff can is written. So here you go to buy a normal can, but you see the Duff recommendations, and you tend to buy the better product, which is recommended. Similar way, when you buy the can, the next recommendation, that is the shirt, Duff shirt, which will be recommended by the software, would again after you buy the can, you would be tempted to buy the shirt, and so on. The recommendations keep going. Similar way, these two, this is the same person and a different cyclist as well. A cyclist buys these three items, and the other cyclist just buys these two items. So, since these both are common in both the places, this item would be recommended for this person to buy as well. In our day to day lives, we use Netflix, Facebook, Google, Twitter, Amazon, Spotify, etc. to see the recommendations. For example, in Netflix, we see the recommended shows. In Amazon, we see recommended products. In Google, we see recommended search results. In YouTube, we see recommended videos. In Instagram, we see recommended users, etc. This is on Amazon. So when you buy the first aid kit, along with it, you are recommended to buy an an extra pair of gloves and all the stuff. In similar way, the construction site, when you buy the suit, you're recommended to buy the other two lights as well. In a similar way, these recommendations keep coming up in different websites. So now let's move on to applications of unsupervised learning. In unsupervised learning, as we have seen, there is a huge sector. There's news. Firstly, it's used in news sections. So in Google News, you often tend to wonder how it understands what topic you're interested in. Depending on your search results and your history, Google tends to collect the data and and analyze the usage and give you the results which are related to your interests. For example, here we see it shows related stories. To you search up Iran holds 10 US sailors, and then it shows you recommended videos below. It predicts that you have interest in these particular fields, and hence it can lead you to different videos. The second use application of unsupervised learning is computer vision. Computer vision is mostly used to detect objects and persons or any handbag, truck. For example, in this picture, we see traffic light, handbag, person, and truck car is identified by the system. And this is done by using unsupervised learning and as well as some neural networks which is involved. Then we have medical imaging. Medical imaging is basically scanning of your brain and like finding out which part is more segmented. It helps doctors easy to analyze which part is more, accurate for the to diagnose for the patients and the pathology, it's used in pathology and radiology. Next, we have the anomaly detection. This is where you group a huge number of data points together. In a data set, you have huge number of data, and you have points which are far away from your group data. For example, in this diagram, we see F1 is way far away from G1 and F2. So hence, this is called anomaly, and even F3 is called an anomaly because it's not anywhere near the points of the group data. Hence, we avoid F1 and F3 to increase the accuracy of your model. Then we have customer personas, where we customers use data day-to-day lives, and it is used by businessmen in order to get profits or understand how a customer performs his day-to-day activities. And then we have recommendation engines, as we have discussed before: Google, Facebook, Netflix, Amazon, YouTube, and Spotify, Instagram as well. Now let's move on to clustering. Clustering is basically a technique in where you plot all the points of your data set, of the unlabeled data set, and then you see the similarities and differences, and you tend to group them together. For example, you see all these green spots together, and all the blue spots together, and all the red spots together. So this grouping helps you to identify which item belongs to which group. So then we move on to the next one. So basically, your data set is a mixture of circle, triangle, and rectangle. And then after you use unsupervised learning, you tend to bring all the same colored items together: pink together, blue together, or yellow together. Or you can also do another way where you can bring all the shapes together: circles together, triangles together, or rectangles together. So now this is how a data set looks. A dataset consists of instance and features. The rows are called instances and the columns are called features. We split the dataset into training data and test data such that 80% of the data is for training and 20% is for testing. So the more percent we train, the more accurate your model is. So hence we tend to take 80% training data and 20% test data to know how accurate your model is. And then we move on to k-means clustering. K-means is a very common method used in most of the unsupervised learning methods. It's basically a process where you group all the same category things together, and a larger value of k will be indicated by smaller groups having a smaller k value. So this will basically group all the greater k-means together and the lower k-means together. Next, we have hierarchical clustering. This hierarchical clustering is also known as hierarchical clusters. So basically, this is a diagram which shows you a dendrogram, where it shows you where each category is divided into and how many categories each category can be divided into. So the two ways in which it can be divided, two types in hierarchical clustering, which is agglomerative and divisive. So in agglomerative, we say it's bottom-up approach. As you can see in this diagram, we move from bottom to top. So agglomerative is when you go from bottom to top, and divisive is when you're coming from top to bottom. This is the only difference between agglomerative and divisive, but they both are commonly used for hierarchical clustering. So now k-means and hierarchical clustering are two different things. So as you have wondered, like why there are four colors on the graph, it's just that there's too much noise in the data. Noise meaning you can say inaccurate data. Like suppose you have one and your data has 1 1 1 1 2 2, and then there's a random 100 out of nowhere. So the 100 is called noise, like it's disturbing the data. So hence it's called noise. And sadly, these both do not represent the noise properly. So these fail to represent the cluster data points. So hence we need another solution for this. So we found another method called dbscan. Then dbscan is a density-based clustering algorithm. That's the full form of dbscan, density-based spatial clustering of application with noise. So dbscan is basically where you show the noise with the help of clusters and show which area is dense and which area is which has lower density and which has higher density. It groups densely grouped data points, and it's basically a single cluster data. Then we have dbscan, which is not able to cluster the data points correctly, but it perfectly detects the noise in the data set. So now you must be wondering, there must be a question like, this is obvious question, like why are we learning like this method when we have k-means and hierarchical? So basically, k-means and hierarchical both failed in creating clusters or arbitrary shapes, as shown in the previous slides. So hence, they're not able to form cluster-based or varying densities. So hence, we're using a DB scan, which is another method of unsupervised learning to help understand it better. For an example, let's take the data set. So this is the data set. So as you can see, the circles, they're present in concentric circles. So we can see three different dense clusters in the form of concentric circles. So the noise here is this, the surrounding parts which are far, far away from the points. So now I would like to move on to the programming. I have made a small demo on FIFA 20 full final. It's basically, I have a data set of FIFA 20 which consists of 104 attributes. So I have a data which has 104 rows and columns of data. So this URL of player, this position of player, and what role they play in the club, and which team they represent. And then we have the skills like attacking, then defense, then mentality skills, GK skills, etc., and so on. And then we have nationality, club, date of birth, and we have like so much. It's a huge data set. So hence we need to, in order to analyze huge data set, we use clustering method. So here we started with k-means. First, I started by using k-means. So first we need to import the required libraries, which are NumPy, Pandas, Matplotlib, Seaborn, sklearn. Sklearn preprocessing cluster metrics are part of sklearn itself, and even these clusters are needed to plot these clusters in the graph, and warnings are needed to be imported to show warnings during the execution of the program. So we set the here we use pd.setOption max columns 104 104 because we have 104 attributes in a data set. And then we import the data from the CSV file, which is given to us. We use pd.read_CSV. So this is a common method of reading the data set. So when you have a data set, you give a variable name is equal to, you see pd is pandas. I have imported pandas as pd. So then we import pd.read_CSV and the name of the file. Whatever name of file you have to just input it here, and you'll get, then you have to type df.head, and you'll get the top 10 top 5 results in the results below. Then if you want to know how many columns and shapes are there in your particular data set, you can use df.shape. So this shows you how many columns and rows your data set has. Then df.data dtypes shows you what data type each column is. So for example, my dataset consists of SOFIFA ID, player URL, short name, etc. And so SOFIFA ID is integer, and player URL is object, short name is object, so on. And here we find some float values as well in between. And then we find, yeah, objects, integers, and so on. So we have different kinds of data sets here. And then we write df.info to see the summary, like summary of what all columns you have, and what is the range, like what are the rows, what are the data types, how many each type of data, like each data type, how many are there. For example, float has 16 columns, integer has 45 columns, object has 43 columns. So it uses the memory usage is not needed as of now because that wouldn't matter as we're doing it online. Our dataset consists of, yeah, this is what we have seen from df.shape. So from here, this is the summary we get from using df.info. Then we use df.nUnique, which shows you number of unique elements in the data set. So you don't want the ones which repeat twice or thrice, which would anyways be the same thing even if you have them, which would disturb the data because repeating the same one would like reduce the accuracy. So hence we want to know how many unique elements are present in a data set. So then we use df.nUnique, and then we come to know how many unique values are there in this. We get certain values. So then we say the data type is integer. We converted all of the data types into integer type. Data type is int64. So here we see next we go into the percentage of missing value sorted. So now we want to know how much percentage is there before we clean the data. So this is called cleaning the data. So we have to clean the data before proceeding with any method. Cleaning is very important. So first, when you want to clean the data, you have to first take the average, and then you have to find missing. You have to write missing values, and if missing values is greater than 0, then you say in place equal to true, and then in that case we get the percentage 0.01313, and so on. It keeps going, so you know where exactly you need to cut off and where exactly you need to replace, etc. So now here we see the data type is float, and then we want to know how many null values are there. Now we have checked how many unique values are there. Now we want to know how many null values are there. So if it says false, it means there are no null values present in it, and if it says true, that means some null values do exist inside there. So hence, if there are null values, we need to cover them up because data set cannot be left empty. So to fill those, as you have seen, which has higher number of nan values here. From here, we come to know that certain columns have a higher number of nan values. The nan values meaning null values. So here we have to drop those because those would again affect the accuracy of your data. So hence we drop player tags, loan from, etc. As from above here, we've seen that loan from has 94% and nation position, etc. have like more than 90%, which would really affect your data. So hence we need to drop them. So hence we dropped all these columns which have higher percentage, and then moving on we drop the columns. Yeah, this is the dropping part where you check the data. This is before dropping the data, and after dropping the data these columns should be missing from the data: player tags, loan from, nation position, and so on till player traits. So to check that again, you would drop all these, so FIFA, player URL, long name, DOB, etc. And you would check df.head. And here we see all those columns are removed. So here we only see short name, age, height, centimeter, etc. But none of the above are shown below. So we have dropped the columns, and now let's move on to now let's identify the duplicates. Now the duplicates affect the accuracy because if you have two data of the same value, it would affect the accuracy in an overall average count. So we define a function get duplicate columns, and then we write a for loop, and then iloc is used to specify a range between rows and columns. So first we give the rows and then the columns, and then we use another for loop, and then again we use the range for rows and columns. So since we're only dealing with uh, columns, we don't specify anything in the first half. In the second half, we specify what variable we're dealing with. For example, we say for x in range, so I'm writing x here. So I'm writing for y in range, I'm writing y here, since it's only the columns we're dealing with. And then we have the duplicate columns come up here: st, rm, cb, rcb, etc. So these are all the columns which have duplicate in them. So now we have to drop all these columns. So we see all the columns again. to verify we don't have any of these in them. So after dropping these, we see a list of all the columns which are present in the data set. So here we see the data type as object. So the object data type, we have age, height, centimeter, weight, kg, etc. And then we plot the heat map. The heat map is basically plotted to know the correlation between two variables. For example, you want to know correlation between age and height. So then you check this particular column. And then if you want to know difference between height, centimeter, overall. So this is basically a heat map which deals with each column with each column. Suppose age versus height, age versus weight, age versus overall, age versus potential, and so on till the end. So, and this is the heat map which shows the intensity of your data set. So we have the heat map here. We just use df.core to plot the correlation, and you can specify the height and width of the figure you want. And then you can also choose the color here, line color red. And you can also choose how much width you want of the data set. I've chosen zero point 0.5 so it's easy to show the graph. But since it's a huge data set, I've chosen zero point 0.5. If it's a small data set, you can even go for one or two, depending on your data set. You can also try SNS heat map or CMap equal to blues, which would change the map into blue color. So instead of red, it would show you blue. Then moving on, we have number of players for each categorical variable. So we have taken names is equal to df.short name to list. Here we are dropping short name because first we take it into a variable short name. All the short names are taken into a variable names, and then we're dropping the table, the column short name. Access g is equal to 1 is important because you're dealing with columns. And then we fill the null values. Now from above, we have seen that we have had few null values from here. We have seen that many of them are false, but since ls, st, all of these have true, so we have to get rid of them because null values is incomplete data set. So we have to fill them with mean values. So hence I've written df.fill_na. So everywhere there is an empty space, it is filled by the mean of the entire data set. And now we're checking again, like if we're checking if any null values are there again. If it is there, then we add it. So then we found out that all these other columns were rectified, but these, which are integer values, are remaining still. The object ones were particularly removed. All the duplicates from the objects were removed, and the integer type are left back. So now, again, we have to do the fill na df.mean in order to fill the null values again. Then we say df is equal to df of all the columns. To get all the columns, you can just say df dot columns, and you get all the column names. So df.head is just to check if all the columns are as per the requirement and all the duplicates and all the data has been filled. And as per the data shown, everything is filled and accurate. So we don't see any null values here. It's fully occupied. So then we say df.shape to check the number of columns and rows, and it's 18278 and 50. So now the number of columns is 50. So now we have the distribution of physical attributes. Now to represent your data, you need to do it either through a bar graph or pie chart. So hence I'm using PLT, matplotlib, in which we have imported in the beginning. Import matplotlib as PLT. And then I'm using RC params for the figure size. And then I'm using count plot and then data set of which column you want to plot, and then that in pink. So as you can see, the second one is plotted in pink, and then the whole data set would be in pink, but in a different color, like a shade of pink. This is the darkest pink, this is a little lighter version of pink, and this is the lightest pink. So hence we say title, plt.title. The title basically is the heading of the graph of what you're representing. So I've written international reputation of the players, so which represents the players' reputation. You can choose the font size here. You can modify it according to your convenience. And plt.show shows you the bar graph. And then we have from sklearn we have to do pre-processing of the data. So here we have to fit the data using min-max scalar function, and we have to fit the data into we have to fit the scale data by using fit transform, and then we call the head of xnorm, and this error shows up. This error usually doesn't show up, but so it will come. So df is not defined because it says df is not defined, but according to the previous data set, df is defined, and we found out that the shape of just a minute. Yeah, just from above, we have seen that df is already defined, so it should work. Yeah, this is not needed when you I have done the pre-processing later on, where I'll be showing you. I'll show it later below. I have done the pre-processing after because it's showing an error here, since we have not completed any of the cleaning of the data set properly yet. So here we see that the we have adjusted the minimum and maximum values. The error shows up, but the changes are done inside the data set. Hence, we can see that the variables are grouped on the player clusters, and the next step is to reduce the dimensionality of the data set. So before we move on with the k-means, we have to reduce the dimensions of each. For example, we have the data in 2D or 3D. We have to reduce it from 3D to 2D or 1D to 2D, etc. We use this particular method from sklearn. PCA is the full form of principal component analysis, which is used to convert the components into 2D or 3D or so on. So then we use the elbow method here. I'll open the file again so that the outputs are visible. Yeah. So I'm running the program again from the beginning. So if the program is run successfully, you will see a tick mark next to it. And if it's not run, you will see an exclamatory mark. So here we say that it says that the player20.csv is not found because I'm using Google Colab. It's not able to identify my data set. But otherwise, if you have it on your PC, you can directly use dfpd.readcsv, or you can, if you're using Drive, you need to use the folder function, and then you need to import Drive, and then a certain pop-up comes up, and then if you run this particular data set, your drive is mounted into your Colab. You just have to allow. So moving on to the next step, I would like to show you. We have stopped at, yeah, we have plotted the correlation matrix, and then we have come here. Yeah, we have filled the mean values, and we have done the pre-processing. So now here what happens is we fit the data, and we have checked the columns and rows here. Just a minute, the output has come. So you need to specify df is equal to path. Yeah, now it should work. Yep, runtime for now. Yeah. Now, as you can see, we're getting the output. You have to, if you're using the drive, you need to use path, and then you should call it using read underscore CSV of path. Or if you can enter the path directly into the bracket, it works as well. So we have got the output for everything. This is the heat correlation matrix, and yeah, we have stopped here. Elbow, yeah, elbow method. So elbow method is basically used to find which point you need to cut the data. So here we have we have to import k-means from sklearn.cluster. Then we say I just named a variable as an empty list, and inside the empty list I wrote a for loop for 1 to 8. So from 1 to 8 we say that k-means if n underscore clusters is I, so it moves from 1 to 8. Since we see here only 8 is the maximum value, so you have to write a for loop for 1 to 8. 8 is the maximum plottable in this particular condition. So then you can choose your range. It can be up to 1 to 8 or 1 to 10, depending on your data set. So in my particular data set, it's from 1 to 8, and then you say comma the variable, the empty list, which I have said here. And then we say we see the elbow method, and from the elbow method we should see the second the break where the graph takes. So from here to here we see a smooth one, and here is the sudden break. So this is the third point where you have to cut the data. So k-means is here we take n clusters as 3 from the elbow method, and the random state is 42. You can take any random value you want, but 42 is usually used to plot such graphs. So here, how to take n clusters is equal to 3 is by using elbow method. So where you see a sudden break in the graph, uh, at that point is where you have to enter the value here, and then you can say fit underscore predict. You predict the graph, and then you get a list of one and zeros. It is very huge, so it's not visible here. So you see dot dot dot. It's a huge list of ones and zeros. And then from sklearn cluster we import k-means, and in k-means we say n clusters is equal to 3 from the elbow method graph, and we again fit the data, and we predict, and then we find the centroid of the k-means data of the data set, and then we plot the cluster. We plot the clusters. Then we print the centroid, and we take Szilard score. For example, Szilard score is basically used as an alternative for when you can use any method which you feel comfortable with, but to know how accurate your data is right now. So you use Szilard score. So you calculate Szilard score and you print it. So you get these values. So my Szilard score is coming around 0.478. Then we make up a data frame by adding player names and the clusters. So then the new reduced we have reduced above here. We have done the I'll show you pre-processing. So pre-processing. Yep. Here we have done the pre-processing before, as you have seen. So we get all the values in terms of zeros, 0 point, so on. So now we got the output from here. The pre-processing, we have df.values, then we just fit the data, and we get all the values in 0.6, 0.2, 0.3, 1.0. It'll be below 1, and all the values will be below 1. So you'll get this particular data set, and from this we have plotted the PCA here. And now coming down here, depend from the graph, the reduced cluster, that means the one which we have fit, the latest one. is used here as clusters. We have stored it in clusters. We're giving it a variable name, and then we're storing short name into names. And then we reduce the columns x comma y, that is clusters and short name. We reduce these both columns into x and y, and then we get the values of x and y in negative values here, and clusters, how many clusters we have for each. So here we have two, and here rest we have zero, and the short names of everyone, and so on. And then to count how many are there in each cluster, I wrote a for loop, and for loop to count how many clusters are there in each cluster. I mean each group. So now we have divided it into groups. K-means is where you divide data set into groups, as I said, and you ignore the ones which are in the boundaries, which are far away from the data set. So here we see in the first group we have 7951 data, and then the second group we have 8289 data, and the third group we have 2038 data. From that, we use the scatter plot. So scatter plot is a way of representation of your data, which is very important for analyzing which part you need to analyze. So here we have hue is equal to cluster. So cluster is the type of design I've used. You can say you can see the spots; those are called clusters. And here styles I've used k-means dot labels. So I have used the labels here, as you can see in the right, what stands for what. And I've said palette is equal to orange, green, blue. So orange, green, blue is the colors of the cluster I've chosen. So here I've chosen cluster centers to this. So we have added the cluster centers of added and found out the centroids of each group. So when we found the centroid of this one, we found out that the x is the center of this. And when we found it for this, this is the center of the green one. And for this group, this is the center of the blue group. So we found the centers now. Since that method is not enough, we can try improving by using another method of clustering, which is hierarchical clustering. So again, we define head. Since we have already cleaned the data, we don't have to clean each and every time. So we can just check the head, and we can proceed with sklearn and preprocessing, and we get the values here. So again, we get the values, we again fit the data, and we get the values in zeros and one, below one, 0 points and below one. Then we import SkyPy cluster hierarchy as SHC, and then we plot the dendrogram. The dendrogram takes time to plot as it's a huge data set. Um, we can say this is the common method used. You can say x norm comma method equal to what, which shows you the graph of your, not the graph, the dendrogram in the sense which we have seen previously here. You'll get a diagram in this shape showing each category and how much it's clustered. So the output will take time. Then we have the vertical line with maximum distance. The diagram is to be loaded. It's loading still. So this is taking time to load. Okay. It's running. So from this we get a dendrogram. which shows you the four clusters. It'll show you a horizontal line which passes through distance. Yeah, that's the same dendrogram as we've seen before. Supposed to load. You can always refer to websites for data. To learn about machine learning, I personally visit there's a website called Towards Machine Learning, which tells you a lot of information about the unsupervised and supervised learning. So in this particular website, you have various articles where you can refer to about XGBoost, vectorization, and many other methods where you can actually work on with many other functions, not only machine learning, but even deep learning, AI related. If you're interested to learn, you can always visit any of these websites. Okay, since the output is taking time to load, um, I'll proceed with the next process. You will be getting a dendrogram, but I think by the time I finish completing my explanation, the graph is ready. So we plot the size again. So here we use figure and the size of the figure. So 20 is just the height and width, and then we have dend is equal to is just to plot the dendrogram, and then PLT is used as a matplotlib function, and color R is red, I believe. And then since we know that number of clusters is for our data set, the next step is to group the data into four clusters. So what we do is we use agglomerative clustering. As we have seen in the PPT, agglomerative clustering is the bottom to top approach. So the data points are isolated here. So we have to separate the groups initially and then merge together. So from the base, we see where all are scattered, like different categorized differently, are brought up to one common place. So this is called agglomerative, and divisive is where you split one into many other categories. So in this case, we are using agglomerative method. Um, and then we predict the clusters. We predict what we will get in the output. So by using agglomerative clustering, we can predict what kind of data set we are up to see. And since from the graph, you'll see that we had four clusters and we had four labels in the output, that is 0 to 3. Since in Python, the indexing starts from 0, you consider 0 as 1 and 1 as 2 and 2 as 3 and 3 as 4. And as final step, we plot the clusters in the below. The diagrams will take time to load. Since it's a huge data set, it is taking time to load each and every aspect of the graph. So we would get a graph showing different colors of the scattered graph, and then since this method as well is not satisfying for us, the diagram would be done in like 2 to 4 minutes, I guess. So hence that method is also not satisfying. As I showed in the PPT, it's not loading there, so I'll just explain from here itself. As we have seen in the PPT, K-means and hierarchical clustering, both of them fail to cluster the data points. They are not able to group them together. So in that condition, we use dbScan, where it is able to group the data together, as you can see. As you can see here, the data is being mixed with different kinds of data. I mean, like data set has different kinds of data, and here the k-means and hierarchical clustering is not able to do it. Here dbScan, you will be getting a graph as such, and it will be able to classify different columns in different concentric circles. Then moving on, so we have used dbScan. So I've imported pandas and numpy again, and then I have called from my drive. I've imported my data, and then I've checked the shape of the data. Then I've checked what all are there inside the data set. And then we say, I will move it from here. Okay. So I've imported the file from Google Drive, and then we say df.shape, which will show you again the rows and columns, and df.info again shows you the data type. And then we find the NaN values in the data set. In the data set, we see that columns have, from the data set we get below here, we see that the type is float, NaN values. I'll just stop this and I'll continue from here. So it's running. So we see that we got the data set. You'll know if if the importing is successful if you write df.h and if you get the data below. And df.shape shows you the rows and columns again. And this is df.info shows you the total information of the entire data set. So here we have data cleaning. We have to fill again, we have to fill the NaN values with mean. So here we have done that. Data set of this column is to be filled with so and so. And in place equal to true replaces all of the mean values with mean. And in this particular column, we're replacing with median. You can do it with both. Hence, I did it with both. You can use mean and median to replace the NaN values. So by doing those, we replace them. And you can also specify that it's very important to specify the type when it's integer. And then we have df.fill and it's successful. And then we have this. And then we write a for loop because we have to change all the float types into integer type. So if you have different kinds of data, it's difficult to deal with. So hence we convert all the float types into integer as well. So we typecast the data, all the float values to integers, and we get these. And then we see play tags, and we replace all the hash in the data set. As you can see, um, will be a hash. Every player number has a hash in the data set. So hence, we have to replace the hash with the space or nothing. You can just replace the hash with nothing. So you get rid of the hash and you convert it completely to an integer type function. Then we're doing the data visualization. So here we see all the hash is gone, and we get the numbers properly. And here we can see data visualization is a method where where you plot and represent your data set, represent your model to your to whomever you're showing it to. So here I've imported matplotlib, and we have done the labels. We get a pie chart as such to see the international reputation of football players. So here we can see that one represents, we have split the labels into five, 1, 2, 3, 4, 5, and sizes as well, international reputation. And here we are using colors 015. 015 is basically the colors used here. And we have given the explode values, and then we have told the style. You can configure them as per your convenience, like what style you want and what shape. Is it a pie chart, bar graph, anything you want, you can configure accordingly. And then here we specify the figure size 9 by 9, and then the title we have given here, international reputation for football players. And then here I have plotted the this is the reputation pie chart, and here I have plotted the comparison between position of the players. So we have right wing, left wing, CA, center, mid, GK, etc. We compare all of them, and we come to know where each uh, which data set is having more number of players. So as you can see in this, the substitutes are the highest, and the reserves are the second highest, and the remaining are average. So we can plot it using set title. No, we can plot it using set x label and set y label. You can always set the figure size, and you can use count plot. Then you say plt.show to show the graph, and then again you show the figure size, specify the figure size. Then you say work rate, and then you say the title on top what you have to write, and then you write the work rate here. These are the work rates. That's medium or low, high or low, high, medium, high, how they're being paid, and number of players being paid in that particular thing. So as you can see, medium low has comparatively more than high low players, and then medium is the highest that the players are being paid. Then we can, these are just different types of representation you can always do to make your model outstand other models. So here we have fig size again. And then this plot is basically this kind of plotting where you plot the points on the bar graph and you join them to form the heights to which they rise in the graph. So we see the different weights of players and heights. So heights is here, and the weights are represented by the line, and we say count of players here. So for the model, we have to do the model preparation. So we say df equal to all the column names. To get the column names, you can always say df dot columns, which would get you the, yeah, just a minute. Here code df dot columns, and you'll get the columns. Yep. So here we run this, and we get object is not calculable. Um, oh yes, since these are in the top of a type of object form, we cannot show the integer format of this. Since these all columns have alphabets, or you can say object meaning alphabet names, etc. It's not able to show you the column names, but these column names you will get from the data set above, where we have checked here df.head, sophie id, player url. You can always get it from there. We have done the df.columns, okay. And then we again fill the mean values in all the empty places. So here we said only the numeric columns. Since dataset consists of object type also, we only consider the numeric ones. And then here we said df equal to df dot fill na. That means that everywhere where there's an empty spot, we fill it with the mean value. And then we save the short names into names variable, and then we drop the short names. And then we have pre-processing again. We again fit the data, and we follow the PCA, principal component analysis, which is the same thing, and we plot the graph, principal component. As you can see the graph, we have changed the background color as well as it's visible more. So we have taken x to be principal components and y-axis to be explained variance, and we get this graph to plot the variance between principal components. And then from this, we can see that 2 or 3 columns would be better because 85% of the data is showing you a variance here. So we go with 2 components, PCA equal to 2, and we again we do we again fit the data into projected calls, and then we print before PCA. And again, df underscore projected. Projected basically shows you the values as we did before on top. We get the values in negative and below 1. All the values you get below 1, and we have also done it here. Yes. We have made a new data set and we have put all of them into x and y variable and we have shown it here. Similar way, we are doing it below also. Yeah. Yeah, similar way, we have done the same thing here. And then we again projected the shape. So to know how many rows and columns are there. So we have reduced it to 2 columns, and we have seen names. We have stored it in names is the short names which we have stored here above. Names is, yeah, this is the names we have stored, and we are here, we're calling it. So the graph takes time to come since it's a huge data set again. So from sklearn.cluster, we see we import dbscan, and model equal to dbscan of EPS is equal to 1. This is all a fixed one for most of the experiments, most of the projects you can say, and you can choose how many samples you want for each column, etc. You can choose depending on your requirement and your data set. You can say EPS equal to 1 and EPS equal to 5, but if EPS equal to 2, depending on your data set, you need to change this value as well. So then we fit the data and we predict the values, and then we make a new data frame by adding players' names and the cluster values. So here we say df underscore projector cluster is equal to df underscore. We store the cluster column into clusters, and then we print the top 10 values. I think the graph is taking time, so we'll just stop the graph. Okay, this is just a small part of the graph. It takes time to plot the graph. dv underscore is okay. I need to run this. Now I need to run this. Yep. Now we got the values of x and y. And then we set the SNS using Cbond. We set it as white color, and again we have to plot, so it will take some time. Plotting of graphs usually takes time because it needs to plot the scatter various points of the data set in the graph. PLT show. So then we plot the DB scan, and we get a graph. So then we use the k nearest k nearest neighbor. Uh, let's stop this. I think it's not coming. Yep. So as you can see, by using k nearest neighbor, we have found out the distance. We have to solve the distance between two arrays. Like we have two columns, right? So we found the distance between those two, and like we drew a graph to know what is the distance between them. So this isn't accurate as it represents the goalkeepers versus the rest of the entire football players, which is straightforward, back to defense, etc. So then here we take training the model is 30%, zero point 0.3 as EPS and 5. And then we have DB clusters and we fit it into the columns. And then we take cluster column into DB underscore clusters. Then again, we use DB scan with new EPS. Then again, we will get a graph here. And then we're plotting a new optimal epsilon with zero point 0.3. So 0.3, only difference here we do is we set EPS equal to 0.3. EPS stands for epsilon, where we have given here EPS equal to 0.3. So we are plotting a graph after that using epsilon. And get the output. Okay, the graphs are taking time. So I'll do one graph at a time. Let's come from the hierarchical. I'll load all the graphs now as we have almost completed the project. Just a graph. Hierarchy. Yeah, here. We run this. I'll plot a dendrogram. Clustering. Show from here. Yep. So this is the heat map we did. Yep, this is what the dendrogram looks like. So here, as you can see, we import hierarchy class from here. Import skipy cluster.hierarchy as shc. So that is, you can always like specify any variable you want. So this is the dendrogram we'll get. We take the value and we return the linkage method. So for each minimum distance, as you can see, this is split down, 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 and it goes down. This is agglomerative method. And here you can see the vertical line with the maximum distance is the blue line. Like red line is like a little shorter than this. So hence we can say that it cuts into this one cuts it into four types: one, two, three, four, and then it cuts. Then it moves further into many other. Then it moves further into many other categories. If you draw a horizontal line, it passes through the longest distance without any floor cluster shown in the figure. So here we can specify the size of the figure. Then we can name it as dendrograms. Then this is the common method. This is the graph that is supposed to load over here. And below that, we'll get an array of 0, 2s, and 1s. And now moving to the last part of DB scan, where we have, since the graphs are not loading, I'll have to load it separately. First, we'll get a graph like this. After completing the um, fitting of the player names and their clusters in X and Y, we'll get this particular graph, which is not that proper. So this isn't accurate as, yeah, this is the goalies versus the rest of the players. Hence, we can only see the goalkeepers on the border and rest of the players are entirely inside. So this is the graph for that. And this is the graph where it shows, which is the reduced one, reduced method of the data set which we got. We have fit the data here by using nearest neighbors. We calculate the distance between each point by using this formula. We say n underscore neighbor equal to 2. So then we fit the data using nearest neighbors. And then the distances comma indices is the values you provide using numpy to sort it. And then you get the graph. I think it's supposed to run. Importing from the drive. We mount from the drive. We got the data set. Yep. So we would get a graph as. Will take time to plot again. Yeah. So that is as of this model. This is the data set. I'll show you in Google Sheets. So to make sure your data set is imported into your Google Drive, all you have to do is go here. Path is equal to specify the path. You can get the path by giving a right click on your file. I'll show it how it's done. You can right click and you can always see view details and you'll see the path where it's stored, location. And if you click on that, you'll get the location of your file. You can copy and paste it in path and you can you can paste it in path and you can write read underscore pd dot read underscore cv of path and then you'll get all the values of your table. So this is the data set we had. This is the Sophie ID. This is the player's URL, and then we had short name, long name, age, etc. And then in between we had null values as well. One minute. Yeah, as you can see, these are all the null values here. So we have filled all those null values with the mean values, all these null values with the mean values, and then we have these empty columns as well, where we filled all of them with mean values. That is as of DB scan. So this is the graph we get in final as well, showing the number of goalies and players, and that is as of now. So you can always refer to other websites for resources. I personally would recommend going on YouTube, and I've always followed like for machine learning crash course from Edu. Yeah, there's always a crash course, but I always recommend going for Edureka or Simply Learn because these two have helped me learn a lot of concepts. I have learned everything what I've explained today. I have learned from these two videos and from Coursera, where the course is available. So you can always go onto websites and explore. So this is a free course, just available by Stanford University. And you can also visit other websites to towards machine learning is a good website. You can always go into that as well. They have different fields, different XGBoost, etc., different methods, uh, different algorithms, etc. You can always explore NLP. NLP is a very good um, method, neural language processing, and then we have a lot of them. So anyone interested can further research here. And as of now, today, that's it. And yeah, thank you. I would like to conclude by saying I've been given an opportunity by VITMAS. Please don't forget to like, share, comment. Thank you.